So like our last example that was sort of a differentiation challenge, I wanted to go through a few more with you, and these I purposely didn't cover anything up because I really wanted for you to see, I don't know, all of the steps, I guess, that you would have to do. When I'm doing these questions, I typically don't write any of this stuff in pink. That's for your benefit so you can see what's happening, but feel free to write that if that helps you to understand what you're doing each step. So let's just take a look at it step by step. I've got two functions here. I've got the original function, which is x squared, and then the square root of 1 minus x squared. So I would rewrite the original function because I don't like this radical. We always want to turn those radicals into rational exponents. So this is my original function. This is f of x. That's the one I'm going to work with. And as I can see, this is going to be a product rule question because I have the x squared as one thing, and then I've got all of this, which will require the chain rule for the second thing. Oh, chain rule, general power rule, all of the above, really. So the product rule says take the first times the derivative of the second, and again, would I typically write this step? No, I would just go straight to this step where I'm going ahead and finding the derivative. And then take the second, which is my blue guy, times the derivative of the first. So I'm differentiating that x squared. I guess I'm using boxes and underlining, and I'm not consistent, so you get the idea. So those two remained exactly the same, and then we're differentiating the other one, and I'm adding those together. So the first one, of course, I'm keeping that x squared the same, but I am differentiating what's inside of here. And that requires the chain rule, or general power rule. That says take the 1/2, move it out front, rewrite what's inside, take 1/2 minus 1, that's why I get the negative 1/2, then differentiate what's inside. So differentiating this, I get 0 minus 2x, or just negative 2x. For my second part, I get this, which remained exactly the same, times the derivative of the first. The derivative of x squared is obviously just 2x. From here, it's just algebra. So hopefully, again, you're really good at algebra because there's so many times that I'm in these videos saying, now it's just algebra, like it's some simple thing, but hopefully you're really good at algebra to get into calculus. So again, I'm simplifying anything I can. Here I'm taking the, I'm taking the negative 2x times the x squared times the 1/2, and multiplying all of that to get negative x cubed, and then times this. So all of this remained the same. And then over here, again, I'm just popped that 2x out front because that's the order we typically put it in, x to the 1/2. And if we can factor, like I have here, we should, because when we get to the end of a question, we really don't want it to look like this, because this is a hot mess and it's really hard to kind of figure out what's going on. So factoring helps us to get to this point where we're going to simplify it back into a format that we would be used to. So if I can take out, in this case, I took out an x because there was an x here, and obviously some x's here, and I also took out this to the negative 1/2. So if I took that to the negative 1/2, what's left over? I'm going to get rid of all of these lines. What's left over if I take an x out of here? Well, that leaves me with negative x squared. And if I take this divided by 1 minus x squared to the negative 1/2, well, that goes away, right? So that gives me 1. Negative x squared times 1. If I do the same thing over here, divide this by x, I just get 2. Divide this, careful here, divide this by 1 minus x squared to the negative 1/2. Those don't cancel. I would actually subtract exponents that would be 1/2 minus negative 1/2, which is actually to the first power. So notice how nicely that sort of happened for me, is that I have this to the first. Now one more step is, now let's write it. like we should, which is not using rational exponents, but using the normal notation. This guy is to a negative exponent, so notice all I did was just sort of pop this guy to the bottom, not the x, sorry, that was misleading. Pop this guy to the bottom. The x stayed on the top. The all of this stuff, which was negative x squared plus 2 times all of that, that stuff stayed on the top of my fraction. So I had my x on the outside, and on the inside, and again, I didn't show all of the steps because there's a step in between, I essentially had negative x squared plus 2 minus 2x squared, and that's what turned into what I have left over here, which is the 2 minus 3x squared. So that's all of the steps to simplify. Again, let's take a look at another one. If you want to practice, write just this part down on a piece of paper. See if you can differentiate it using all the rules that we know. And then I'm just going to go over all of the steps that I have listed out here. Again, this is a lot of rules all at one time. I've got a function here to the second power. So to take the derivative, I would take 2 times all of this to the first power, and then I have to take the derivative of all of that stuff. And of course the derivative of all that stuff is no small task because that's the quotient rule. So notice that this is what I've written as my first step, is I've used the general power rule to take 2 times whatever I had originally to the first power, and then take the derivative of what was inside. The derivative of what's inside is the quotient rule. So notice this, I've really just kept the same. The quotient rule says take the bottom times the derivative of the top. The derivative of the top is 3. Minus, don't forget that one's a minus, times the top times the derivative of the bottom. The derivative of that would be 2x, and then square the denominator. Now I have some multiplication. So I'm just going to multiply what I can. So it looks like I've got x squared plus 3 to the first and x squared plus 3 to the second, so that's a total of x squared plus 3 to the third. My numerator, I've got 2, I've got 3x minus 1, and then all of this stuff on the inside I've distributed and distributed so that I can write it all out, and then I've just simplified what's on the inside. And that's essentially all there is to it.